Okay, hello everyone. This is Jimmy's channel, and I try to sharing something from my perspective, which I thought is really important. And yeah, by this way, just try to remember more things by teaching. Okay, science kind of famous learning method. So today I'm going to talk about the solid principle for design pattern, and we will start to explain with some really quick demo, which is I'll create with order class first, and in that side this order it will have an int private int value. Okay, here's price. Okay, yeah, that's it. And what maybe we'll just use a creator. Constructor. Yes. And later we will create a checker. So every time we'll create this order object, and we'll check whether this order is legal or not legal. So that's what we did. So yeah, it's the same. It's just very principle, and we'll do a Java class distributed interface, which is called checker. Checker behavior. Yes, checker behavior. So inside this checker behavior, we will have first one. It should be let me think. Void okay, because we will have this is you see the file name is folder name is called COR. So this is chain of responsibility to that pattern. So what we did here is to create multi checkers. The first one is fundamental checker. If the order price is less than 100, just do some example. If, for example, less than 100, and we will use the fundamental checker to check. And if the fundamental check find that the value is bigger than 100 and less than 1000, then it will just invoke the maybe manager checker. If the price is still higher than the bar, and maybe we'll just invoke the next level. Yeah, this is called the, core, chain of responsibility to that pattern. And I just go set with check. Okay, the first function is the check. So when we do check, we need to transfer this order, right? So this order will be the parameter here, and the second one is what is set. Okay, I'll just remove this set checker. Okay, let's do it. I'll just do as simple as possible, and I'll just create one more class which is called fundamental checker, which is called junior checker. Okay. My voice just got disconnected. No worry, I just continue on that. Yeah, so for the junior checker, which we need to do to implement with the checker behavior. Yeah, checker behavior, and we need to override this function checker. That's what we did. So for example, okay, let's just continue on this one. Public void checker, and what we did, if order dot get price. Okay, so for example, in this order price, and we'll just quickly with a getter setter. Get price and less than 100. Okay, and what we did is automatic. Okay, automatic. How to say success? Grant success. Grant ACCESS. Okay. And we will just system out with here with the junior checker. It's checking. Yeah, that's the thing. So also we need to invoke with the higher, right? So that's the thing, and we'll just create the corresponding, checker. So it's just called another one, which is called senior checker. Checker. Okay, and we'll just press. Oh, sorry, my voice just got connected. So it's implemented with what holiday? Checker behavior, same thing. Actually, it's all the same thing, and Shift O. And here we just did the same thing, just copy here, okay? Yeah, it's very principle. And check the senior junior. Let's say maybe 1,000. Yeah. And we'll have another checker which is called manager checker, or we'll call it final checker. Okay, it's called final checker. Implements checker behavior and check. Sorry. Yes. Okay. Is there one? Maybe 10,000. Okay, just a very simple example. Automatically final checker, gather access, junior checker, grant access, final. Because on this type. Do not undisturb the chat mode. Okay, so you see what we did here. So every time we try to maybe your access did not have you did not have access to grant for this order, and we need to what new dots. Okay, for example, just to check it. Why do we did not use with bowling? Okay. Just to fix one by one. Return true. Okay, so junior return false, return true. Final check. Senior check. Okay. So this one we will return new. What is senior? This is senior, right? Senior will go to manage. Right? Final checker. Dots check. Order with order. Okay, that's the thing. And junior will return with what? Return with new junior senior checker dot check order, right? Final checker will else return false. That's the thing. LSA. Shit. Okay. It's a very, classic way to do this kind of order, and we will have a order check. Let's say public. No, it should not be private checker. Private with boolean check function. Okay. So inside this function, what do we do? We need to nothing to do. So we need to create with a junior developer checker. No, just it's a new junior checker dot var, and junior checker dot check this, and yep. So this is what we did, and return. Okay, return this this is what we did. And when we try to create this one, we need to invoke this check function. So this is a very classic way to do. That's just there. And we create a main class to do it. Then and we use order, new order. For example, the price maybe was 99. Okay, and we just do run it, go. I forget about that. Just to remove this. This is some conflict with my local Java version, JDK version. Okay, let's run it. Oh, you see, junior checker checking, grant access. Maybe we'll try to with 199. And now we will just include with senior checker. Yeah, that's the thing. If we use 199, maybe 1199. So we will invoke with the final checker will be included. If it's bigger than that, maybe it will causing some error here and return false. Final checker. Dot var order. Yes, the same. Okay, I got a point. So checker, this need to be junior checker, return junior checker. No, it should not be returned, right? It should not only be returned. It should be junior checker. This is so let's see. This is only junior checker down all. Dot var place to curse checked. Okay, and we will set with checked. With order status is plus is checked. Okay, just run it again. Order status is false. Yeah, that's what we did, and we try to think about what we have done here. First, it's in the phases, and second one, you'll find that final checker. Order checker will create with the constructor, and it will invoke with the check every time. It's just during the construction. And here, what you say is the problem here. I just show you some disadvantage for this pattern. First one, we did not extract the corresponding, chain out of this concrete class. We just directly to hard code here. So this is not very dynamic. It did not follow with the open closed principle. So we try to do some optimization for this. Yeah. So for example, this order try to change the order. Change order for the checker. For example, it wants directly to start with the maybe, for example, after junior checker did the check, then the second one maybe will come to another like junior peer checker, for example, like this way. And we need to create one more checker here, but for this time it's hard to change the sequence, so it's could causing some problem. That's the disadvantage for the current implementation. So we need to change to the dynamic version. So let's take a look how we can do that. So that means each checker will have a inner attribute or inner property, which is the instance for the next checker, right? So let's do this way. We create one more, Then we will think about with the abstract class, so which was this checker class. And this one, of course, we will implement it with checker behavior, right? And okay, just to set with abstract class. So what we did with every class need to contain and maintain for the instance of next class. So here, for example, we'll do we will have a checker inside. Private checker is a checker, so call that next checker. Okay, that's the thing. And the second one is yeah, we will have a function to set the next checker. So yeah, better to write here. It's called void, and we set next checker. Yes, it's a checker, right? Checker, right? Yes, that's what we did. And let's go back here. So here, let's just override for this function, because checker is the behavior for each particular checker based on different business logic. So, but the set next checker will have to totally have the same behavior. So it should be this dot checker, right? Yeah? This dot next checker equals to checker. That's what it is. It's a common behavior. So we just implemented for this function in this abstract class. For the check function, yeah, they just did by themselves. So it just come with a junior checker first. So it needs to extend for this abstract class, which is called checker. Yeah. Okay. And we just because the function is already called checker, we already just implemented it. So no manipulate anymore. Just change for this one. And I will just some format for this way. And here it's the totally same. See, extend checker. Yeah, simple, right? And how it comes to the senior one is same thing. Extend checker. So just do some comparison with the previous version. Now each checker here will have a inside will have an inner property which is called next checker. So what do we did here? Like come to this one, order and do the checker. Okay, new order. So here in the new order we'll have a check function, and we can combine different checker. Maybe in the future we'll have a maybe 20, 40 checkers here, and we just combine based on our business logic and our requirement. That's what we did. So we cannot just write with this way. And for example, junior checker. We need a junior checker first. We should not return the code by this way. New junior checker. So dot var. Yeah, that's what it did. And we need the junior checker and a final checker directly. So we can use a final check directly. Just skip for the senior checker. Sorry, not this one. Dot var. Yeah. And also, okay, junior dot 46. So this is a junior checker, and you will say here, I think about it. Sorry, set next checker with the final checker. Yeah, this is what we need to do. For example, if you have more things, you need to set the sequence by yourself. This is more dynamic than the previous version, because just check the previous one. You see, we can directly only set the first with junior, and we cannot manipulate the sequence. So this is more better. It's more dynamic. And so the same thing is same spelling. I should not write this way. Junior checker dot check this. Okay. Now that's thing. What's I should just var to get the status, and at last I just return with checked, right? Okay. Oh. System audit. Final status. I just copy this one. Okay, that's the thing. So you just do the comparison here. Maybe the code will be much more complicated for this part, but I mean the whole design pattern will be more dynamic, flexible. Yeah, that's what I want to share today here. This is the first part. I just give you a bad example for the chain of the responsibility. Sorry. Yeah, chain of chain of responsibility. I think this is called chain of responsibility, and just to do some optimization based on previous version. And you can check for jimmysdebugging.com. jimmysdebugging.com. I'll publish all the kind of source code here. That's a thing. And nothing more. I just give you an example here, and I just run it. Okay. Junior is checking, senior is checking, final. Why senior is checking? Junior is checking. I didn't to change this part. Sorry. So junior one, we need to manipulate this part. So we should use this dot next checker. Only set next checker. Okay, I got a point. So checker, I did not set with a getter setter. Okay. I should write this one. You see that this is junior. Okay, go to final. Final note is senior. Senior with this one. Okay. And just go to run it. Actually, why was this one will come to me? Just to fix this one later. Maybe offline I'll do it, but not this time. Okay, just focus on behaviors. You can see junior checking, final is checking, that's a thing, and just go to the order, and you see here final. New senior. Double. Yeah, it's a good trick. I like to do this with one. I just learn from my manager. That's a thing. Okay, just test. So here, it's a good format. Junior, senior, final. Junior set to senior. Senior set to final. Yeah, that's a thing. Okay, let's run this main function. Go again. Junior, senior, final, checking, order status is false because this is so huge. And if I change with 1199, if I change with 1199, just go again. Junior checking, senior checking, final checking, final grant access order true. Yeah, okay, perfect. That's the thing. So for today, and we'll just talk about kind of. Yeah, this is what I'm going to share with you today. It's just talk about the solid is OLID principle. So S means what? I try to remember a single responsibility. Right? Single responsibility. Okay. Okay, let's talk about this part first. So what is single responsibility? That means orders just do the orders duty and checker do checker's duty. That's the thing. You should not combine everything together and make it a superfluous. That's a very principal one, which is called single and responsibility. I think most of you can remember this. And second one is O. What is O? What is O? O is I think open and closed. Closed. Okay, so open and closed is what we did for the second part. We just try to set this function, set this line, right? I need to do this. Okay, copy this. I just roll back to the previous version. Okay. So open and close means we need to open for add some new feature. But close to the manipulate. For example, we have already done the first version, and later with some new checker getting inside, if we want to change the sequence, we need to manipulate each of the checker because we try to return with this, a very particular class directly in the source code. So if this is the first version, and that is not following the open and closed principle. And if we just come to the simple one, this one, I should not say it's a simple one. It's more, it's because it's following the open and close. So next time, if you have more, for example, why it's always get disconnected from my video. Maybe I will try to use some new one. Okay, let's just go back here. This return this get next checker, or by this way, every time we try to create one more checker, no need to change for this checker class. We just directly create it with new checker, and in order or somewhere like a factory, we can use a factory pattern to optimize this part of the code, and you can just change the sequence by this way. Sorry, I just try to change some machine. I just use some small rig recording one. I think it will have a better quality, but sometimes it got disconnected, and it cannot connect it directly with my MacBook. So I just connect it with my iPhone and use the iPhone as a microphone here. I'll just try to do better next time. Okay, let's just come back to this topic. So we just talked about open principle, open closed. Okay, I think you have already understand what I'm talking about. So the last one is list call substitution. List call substitution. Substitution. Okay, list call substitution. List call substitution is Chinese. Chinese 离式替换. Sorry, I forgot about the one. I'll do talk about that. I mean, I remember that means the child class can replace with the how do you think father's class? Yeah, 这个 child 类都能替换它的接口使用，子类必须能够实现它的父类。I don't know how to explain this part in these functions. I mean, maybe I already understand that. 能够 check 人全实现都能够接口。That means I think we have already created many public phase here, which is called check behavior. And here, for example, so this order I can check with this one. See the final. This is called list T1. Not this one. Cost. Oh, I'm going to check. Oh. It's cost checker. This is called checker, I think. That's what we call it. And for example, if we do not like this way, we can use this, I think. Then this will be no need to do that. But the behavior will totally not change. Not change. It's still the same. This is called list call substitution. Yeah, that's the thing. And we come to the next one is called list call I was what. Let's go in interface segregation. That means we cannot create some super interfaces, because in this demo I cannot show you because it's a very small interfaces. But for example, if I have 20-40 functions here, that's not possible because we can implement multi-interfaces in Java syntax. So you need to break down into pieces in proper granularity for that. This is called, interface segregation principle. Yeah. And last one is dependency inversion principle. Okay, dependency dependency inversion. This is good understanding is that we need to focus on the we need to depend on the abstract class to do the development instead of the concrete instance. Let me just tell you some example. Maybe I can go with some observable pattern. Publisher. Oh, just return this one really easy. Like this one because observe. Let me think. Actually, I think this call of substitution principle and dependency inversion principle are really closely similar, because it's also mentioned about we need to focus on this checker to do the development instead of the concrete implementation, concrete class. Let me ask. Okay, I got the point. So this called substitution may more focus on the extent. That means the subclass should not destroy the behavior for the father class. Yeah, that's a thing. So like this one is called the father is a bird and it has the fly logic, but the subclass is called flies will throw an exception. That means it's break the promise with a father class. It will causing problem because when you try to invoke this bird fly, and the bird will send with a pattern, then this will causing some error here. Yeah, but injection inversion. I always forget how to use solid. Why is it called? So dependency inversion is more focused on the interface parts. You see here, private MySQL database, you directly depends on the concrete implementation, but instead of that, you need to focus on some interface, which is called database. So this call principle more focus on the extents safety and let's see, dependency inversion principle more focus on the dependency. You just depends on the abstract, not the concrete class. Yeah, that's the thing. Okay, thank you. That's all the things for today's part, and I'll just go with some other important principle, which is called composite reuse principle. With this one, it's mentioned that we need to better use the composite instead of extend. For example, we can use the set next function here. We use the set next function here in the abstract class instead of each class just extend with one-on-one. For example, junior extend from checker.
and senior extends on junior, or final extends on senior. That's just not possible. And the limit, law of limit, just to connect with your friends. Limit of law of limit. So that means order. You just only need to communicate with the first checker, and then you no need to care about what's the next one, because the junior checker will transfer this kind of dependent thing internally. So this is what's called the law of Demeter. So many principles here. And a common closure principle is, the similar class should be put together. Okay, that's the thing for today's part. We just spent around 40 minutes, 35 minutes, 36 minutes here to talk about the core of responsibility design pattern, and I just show you the solid, my understanding of the solid. Yeah, that's the thing. Thanks for your time.